Welcome back to the tension test for copper. So the tension test for copper will exactly be the same as the tension test for low carbon steel and aluminium. So this is our specimen. The very first thing which we are going to do is go ahead and tie our specimen into place. And so once you put the specimen, make sure that it is secure, and then take your 1 year caliper, re-zero it once and measure the cross-section area. It is around 0.25 inches. Okay. So once that is done, I'm going to go ahead and bring the head down really slowly, and I'm going to try to fit my specimen inside. Okay, so just going to try to secure the top of my specimen. So make sure that it's really tight. Okay, so once everything is done, I'm just gonna check the software once, make sure it's working. Everything is working so far. Our next step will be the same, to connect the extensometer. So I'm going to take the extensometer over here and just put the grips gently. Make sure that the grips, the tiny flat part of the grips are near the the center of the specimen is near the center, near the middle of the tiny flat part of the grips over here, as shown in the video. And once that is done, take your marker once again and place 2 dots just on the top of the extensometers for visual inspection. So once you're done with that, go ahead and re-zero the extensometer, and then we are going to go ahead and make sure that everything is tight, and then I'm going to go ahead and hit play. Okay, so once you hit play, click OK again like the last time. Everything else is set, and now you can see that our experiment has started. So initially, if you see the data, you're going to see that initially that the load versus deflection has a linear zone. Okay, and that linear zone is going to continue until the linear elastic limit, beyond which it's going to transition to the non-linear zone, and you're going to see the specimen yielding, and thereafter it's going to slowly, gradually go to the ultimate stress zone. Then ultimately it's going to fracture. So when we analyze this data, you're going to see this in more detail. So you can see the specimen, that the necking is starting. So there is a pop-up telling that to remove the extensometer. So I've just clicked paused so that I can remove the extensometer. But after we remove the extensometer, we are going to come back and see the neck zone. Okay, so now I have paused the experiment, and you can see the neck zone. It's very pronounced. Okay, so you can very well imagine how the specimen will be stretched out, and ultimately we are going to go to fracture. We're going to see that. So let me go ahead and continue the experiment. So I have just hit continue, and we are pulling the specimen apart now. So you can see that the necking is getting more and more pronounced. That means we are getting more and more close to fracture. Okay, so that means we have fractured the specimen. So what I'm going to do is click no, and my experiment should be complete. Okay, so just going to go ahead and untie my specimen like we did the last time. So I'm going to take this off, and then I'm going to go ahead and I can show you how much elongation we have for copper. You can see that the copper elongated pretty well. Okay, so once you are done with the experiment, your second last task will be to measure the cross-sectional diameter once again, which will be around 13 or 11 inches. I'm sorry, it will be between 0.11 to 0.13 inches. And once that is done, do the same thing again, export your data, and you should be good thereafter. So once you've exported the data, just go ahead and check it, and you can see the data. So we are all good now. So this is as far as the tension tests are concerned. If you have any questions, feel free to ask your instructor.